Hi everyone, today is gonna be a short video because I have only 3 slides including the thumbnail of the video, but I'm gonna talk a little bit about a different kind of gradient descent algorithms called Stochastic Gradient Descent, and it's used more widely than the Batch Gradient Descent. You may ask yourself why, and I'm gonna show you. And first I'm gonna introduce how it works in 3D, so you can understand it with your gut feelings, and then I'm gonna talk about how it works mathematically. So you see the same loss function graphed as we did with the Batch Gradient Descent. Colors are a little bit different, but the meaning is still the same. And as you remember, in Batch Gradient Descent we take some point, then we go here, here, and here, for example, and we are in the local minimum within 2 or 3 steps, for example. But there is an important thing to know about the Batch Gradient Descent is that each time it iterates through all of the data. It takes all of the metrics with data and reads every number from it, which can be extremely demanding in terms of CPU and in terms of your computer power, because if we have, for example, 1500 objects in our data set, we don't care. We can use Batch Gradient Descent. But if you have, for example, a few million objects or tens of millions of objects, we cannot use Batch Gradient Descent because it's gonna be power consuming, it's gonna be slow. So we use Stochastic Gradient Descent, and as you may see, we go to the local minimum within a few steps. And how do we achieve it? And so we have more iterations, and one iteration almost costs nothing. So how do we do that? We have almost the same formula, but this thing is different. So it's a type of gradient descent algorithm that iterates and adjusts coefficients of the model per one object at a time. So we don't iterate through everything. We just take one object, loss function of one object, and then we adjust all the coefficients based on this random object. And it may seem a little weird on the first time, but here's the graph of the cost function. Here are the layers. We have this thing, but we look from the top on it. So we see, for example, this is our beginning point. Take one random value, one random 1, 1, 1, 1, 1, and we have a certain number of iterations which are not as precise as they look when we use Batch Gradient Descent, but we don't actually care about it too much, and it still helps us to get where we want, and it's less computer power demanding. So it's a little better, I think, and that's everything, I guess. And today, right now, we understand the whole gradient descent from our gut feelings, and we can use it with almost every machine learning and AI algorithm because it's so widely used. And tomorrow I'm gonna introduce you to an interesting part of the linear regression that is called least squares method. It helps us not to iterate through all of the data, but just do a few arithmetical things, and we would get the global minimum of this cost function within just one iteration. So from every point we could get to the local minimum within just one iteration, and this thing only works with linear regression. So it's quite interesting. It requires a little bit more math, so next video is gonna be, I think, a little bit longer, but it's not as hard as it seems to be. So thanks everybody for watching. I hope you stay with me for the next videos, and I hope you write something in the comments because I just need to know what you think about the videos.